So now we are going to look at the trigonometric ratios defined at some specific angles, namely 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. Now, in a right angle triangle, obviously since one angle is 90 degree, the other two cannot be 90 or 0. But these, suppose as hypothetical cases, we can extend the triangles to almost 0 and 90 degree angles, and then we will see what happens. First, let's start with the easiest, and then that's 45 degree. In a 45 degree right angle triangle, A, B, C, 45 degree. So this angle will also be 45 degree, and since these triangles are equal, these two sides will be equal. So let's say this is K, this is K. By Pythagoras theorem, we see that AC is K, root over of K square plus K square, that is root over of 2K square. So this side will be root 2K. Okay. Now we just reduce. First, let's see sine of A, which is equal to sine C, which is equal to sine 45 degree. Sine 45 degree is sine A or sine C, either opposite is K and hypotenuse is root 2K. So we get 1 by root 2. Similar, cos 45 degree, adjacent is K by root 2K, we get 1 by root 2. Tan A equals tan C equals tan 45 degree. This is equals to K by K for both A and C. So tan will be equal to 1. Now taking the inverses, that is the reciprocals, we get cosec 45 degree equals to root 2, sec 45 degree equals to root 2, and cot 45 degree equals to 1. Alright, this we find the trigonometric ratios for 45 degree angle. Now let's see 30 and 60 degree. For 30 and 60 degree, let us assume an equilateral triangle first. A, B, C. This angle is 60 degree. We now draw a median or an altitude. In equilateral triangle, everything is the same, and this cuts at exactly the midpoint. So these both lengths will be equal, and the angle is also divided equally. So these both become 30 degree and 30 degree. Now assuming that the length of one side of the equilateral triangle is supposed 2K, since this got divided equally, both of these sides have K and K. This angle is 60 degree. This is also 2K. Now we know this becomes a right angle triangle on both sides. Let's consider triangle ABD. In ABD, we have the hypotenuse. We know the base BD. We can find out AD by Pythagoras theorem. We get AD square equals to 2K whole square minus K square is equals to 4K square minus K square. This is equals to 3K square. Implies AD equals to root over of 3K. Okay. Now obviously we did not take the negative one for the same reason that we haven't been taking it. So we find the value of this as root 3K. From this we can deduce the trigonometric ratios for 30 and 60 degree. So let's still consider triangles A, B, D. In this triangle, D is the right angle, A is 30 degree. So let's go for sine 30 degree. Sine 30 degree is opposite divided by hypotenuse. So this is k by 2k. This is equals to 1. Cos 30 degree equals to adjacent by hypotenuse. So we get root 3k by 2k. This is equals to root 3 by 2. And tan 30 degree, we get opposite by adjacent. So we get k by root 3k. This is equals to 1 by root 3. Taking the inverses, cosec 30 degree, this is equals to, this was half, sorry, my mistake. Cosec 30 degree is the inverse of this, so we get 2. Sec 30 degree, we get the inverse of this, that is 2 divided by root 3. And cot 30 degree, we get the inverse of this, so this is root 3. Okay, we did for the 30 degree angles. Now let's see for the 60 degree angle. That is still considering triangle ABD, we go for B. Angle B is 60 degree. So sine 60 degree, we get as opposite root 3 divided by hypotenuse 2, root 3k by 2k. This is equals to root 3 divided by 2. Similarly, cos 60 degree, k by 2k, this is equals to half, and tan 60 degree will be, tan is root 3k divided by k. This is equals to root 3. Taking the inverses, cosec 60 degree equals to, inverse of this is 2 divided by root 3. Sec 60 degree is equals to, inverse of this is 2, and cot 60 degree, this is equals to inverse of this is 1 by root 3. Okay, now we know the trigonometric values of 45, 30 and 60. Let's do for 0 and 90. For 0 and 90, let's start with a normal right angle triangle, say 45 degree. This is A, B, C. This is, suppose we are looking at angle C. This is 45 degree. Now let's keep on reducing the angle and let's see what happens. When we keep reducing the angle, something like this, but keeping the length of the base same, BC same, this is less than 45 degree. This will be even less than 45 degree. Even less. And so on until we get the, this is almost miniature line, microscopic, you can't even see, and this angle will almost correspond to 0. Okay, this is C, A, B. B is still the right angle. When C almost corresponds to 0, we see that the length of AB is almost negligent. So we can consider it to be 0. Considering AB as 0, we get the angle as sine 0 degree equals to whatever the hypotenuse is, it doesn't matter, because since AB is 0, this will be 0. Similarly, cos 0 degree. Now the thing about AB being 0 is that AC and BC will coincide. So it becomes AC equals BC, and since cos is cos 0 degree, that is C, will be BC upon AC. That means since BC and AC are equal, this will be 1. Similarly, tan of 0 degree. Tan of 0 degree, again we see that the AB is almost negligent, it is 0, so AB by BC will be 0. And the reverses are of course. Now cosec 0, we know that it is 1 by sine 0, but since sine 0 is 0 and 1 by 0 is not defined, we do not have a value for this, we just call it not defined. keep in mind that 1 by 0 is not infinity. It is actually not defined. It does not have a numerical representation. Alright? Cos 0, since it is 1, sec 0, the opposite will be 1. And similarly, cot 0 will also be not defined. Okay? Now let's look for 90-degree case. Similarly, starting from suppose an angle of 45 degree ABC. When will this angle will only approach 90 degree if we keep on increasing this angle, which means this BC length will have to be shortened. So that's how this angle will increase. Keeping AB constant, we see that this angle changed. See, this angle is obviously greater than 45 degree now, and we continue doing this until we get to a point where it is almost coinciding. B, and this is A and this is C. B is still the right angle, but since C is so close to B that the length BC is negligible, angle C is 90 degree and AB and BC coincide. So again we go sine 90 degree. Now sine is AB by AC. Since BC is negligible, C is 90 degrees, so we are doing AB by AC. BC is negligible, it means AB and AC almost coincide. So AB by AC, since AB equals AC, sine 90 degree will be 1. Similarly, cos 90 degree will be BC upon AC. BC is negligent, almost 0, negligible, so cos 90 will be 0, and tan. Now tan is, in this case, since it will be AB by BC, AB has some specific length, but BC is 0. So something by 0 is not defined. So we call it not defined. For cosec, we see that it is the inverse, so it is 1. For sec, again it can be 1 by 0, so it is not defined. But cot in this case, there is nothing the inverse of not defined. Even though it is 1 by 0, since 1 by 0 is not a numerical representation of anything, we can't write it as 0 by 1. We will see from here that cot 90 degree, angle C is almost 90 degree. So cot will be BC by AB, because cot is angle adjacent by angle, side adjacent by side opposite. So BC by AB, and since BC is almost 0 but AB has some specific length, this will be 0. Okay, we have all now done successfully for 0 and 90 degree. I will draw a table on the side with all the angles and the values, so it will help you refer directly when we do some examples. I would suggest that you learn these angles and the values associated with them as fast as possible, because it will be of a lot of help in the upcoming questions that we are going to do in the future as well. So let's construct the table. We have 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. We have sine, cos, tan, cosec, sec, cot. Sine 0 was 0, sine 30 is half, 1 by root 2, root 3 by 2, 1. Cos is 1, root 3 by 2, 1 by root 2, half, 0. Tan is 0, 30 degree is 1 by root 3, this is 1, this is root 3, and this is not defined. Going for cosec, ND stands for not defined. Cosec 30 degree is 2, root 2, 2 by root 3, 1. Sec is 1, 2 by root 3, root 2, 2, nd, not defined. Cot again is opposite inverse of tan. Tan is 0, so this will be not defined. This will be root 3, 1 by root 3, and cot 90, just as we saw, is 0. We have this table, and it is very important that you memorize this as soon as possible. Now let's do some examples. Okay, so let's try one example. We have a right angle triangle, of course, A, B, C, right angle at B. We are given the length as, we are given the length of AB as 5, and we are giving angle C as 30 degree. Okay, so we have to find all the lengths. Basically, we have to find BC and AB. Now, of course, we have to use the trigonometric identities for that because we have no other information. Now, let's start with sine 30 degree. What do we know about sine 30 degree? It is half. But in this case, sine 30 degree is also equal to sine C. And sine C means AB by AC. This is equal to 5 by AC. Now, multiplying AC both sides and 2 both sides, we get AC equals to 5 into 2. This is equals to 10. Okay. Now, the last BC we can find by Pythagoras theorem, but that will really not help our purpose. We should use the trigonometric ratios of the angles given to help solve, because that is what we are looking for. We know AB and AC, we have BC left. We can solve BC by cos 30 degree. Now you can use any of the ratios that you want, whichever will help you find easy, whichever you think is easiest to help you find the length. But sine and cos are the most used functions everywhere, so we will go with these. Okay, cos 30 degree, this becomes BC by AC. AC we have just found out is 10, so we get that BC equals to 5 root 3 units. Okay, I hope you understand that. Let's move on to another example. Let's say we are given the lengths of sides and we have to find all the angles. Okay, sorry, we are given a right angle triangle. We are given that this length is 3 and this length is 6 units. Always remember, length always has a dimension. Even if I'm not specifying, it must mean centimeter, meter or something. When you say units, it's unanimous, so you don't have to specify. Okay, now let's find out the angles. What can we say about angle C? We know that sine C will be equal to AB by AC. This is 3 by 6. Simplifying, we get 1 by 2. Alright, now what is the value of the angle for which sine is half? We see from this table that sine is half when the angle is 30 degree. So C equals 30 degree. Since we know this is B is right angle, we can obviously calculate this from the angle sum property, that is the sum of all angles is 180 degree. But let's solve using a different approach, using this. Now we know these two lengths, we can find BC by Pythagoras theorem. So we get BC square equals to 6 square minus 3 square. This is equals to 36 minus 9. This is equals to 627. Implies BC equals to, so 9 into 3, we get 3 root 3 units. I am eliminating the possibility of the negative length. So we get again cos C equals to 3 root 3 by 6, eliminating, we get root 3 by 2. Or C, we already know C, so this was redundant. We could have simply done cos A. Okay, we need to know A, so we could have done cos A. Cos A similarly 3 by 6. This was really redundant. Cos A is 3 by 6, so simplifying we get half. We see that cos is half when the angle is 60 degrees. So we find that this angle A equals 60 degrees. Alright, I hope you are with me so far. We'll do another example. Suppose we're just given that sine A minus B is equals to half and cos A plus B also equals half. The additional conditions given are 0 is less than A and both are less than 90 degree, and A is greater than B. These are essential conditions to solve the question, but these will be explained later. Okay, now sine is half, and we see sine is half for 30 degree, so we get A minus B equals to 30 degree. Cos is also half, cos is again half for 60 degrees, so we get A plus B equals to 60 degree. We add both these equations, we get 2A equals to 90 degree, implies A equals to 45 degree. Substituting the value of A in any of these equations, we see that B equals 15 degree. Now we found A and B easily, but if these conditions were not given, the question would have been a lot different, because like I said before, that the ratios, they extend beyond 90 degree. Just because we can visualize and perceptualize the angles only from 0 to 90 does not mean that they do not extend. They extend, but they are repeated, so it will be easy to grasp the concept once you have mastered all the basics. We now know the values of the trigonometric ratios at the said angles, so let's move on to something related, but something I think you should have noticed by now. It's about complementary angles. You know what are complementary angles? Complementary angles are, suppose if we say that A and B are complementary, it implies that A plus B equals 90 degree. Okay, now the thing is, in a triangle, this is a right angle, even though it might not look so. Suppose we take angle A. Now we know, let's start with sine A. Sine A will be BC by AC, but this angle A is 90 degree minus angle C. Okay, so suppose we write now cos C, the value of cos C. Cos C is also BC by AC. The thing to note here is that C, like I said, A is 90 degree minus C and C is 90 degree minus A because they are complementary from angle sum property. Since B is 90 degree, the sum of the rest two must be 90 degree. So we can write this as cos 90 degree minus A is equals to BC by AC. This is equals to sine A. Alright. Similarly, we can prove for all, but let me just give you the end results. We see that, let me erase this. Sine 90 minus A equals cos A, cos 90 minus A equals sine A, tan 90 minus A equals cot A. This is supposed to be cot. Okay, and we take the reverse of cos. We get cosec 90 minus A. This is equals to sec A. We get sec 90 minus A. This is equals to cosec A, and we get cot 90 minus A. This is equals to tan A. Okay. Now I think these results with these tables, these results are really visible. Suppose we take sine 30 degree. 30 degree is 90 minus 60, and cos 60 is also half. Sine 30 degree is also half. We see that these values are just sine values are just cos values in reverse, and cosec and sec have the same thing, and tan and cot have the same thing. So since these are complementary angles, this is what it looks like. Okay, let's do some examples for complementary where the angles are not actually in among these 5 angles. Okay, let's say we have to find the value of tan 65 degree divided by cot 25 degree. Now, as we just learned, tan of something equals to cot of 90 minus that. So we write this as cot of 90 minus 65 divided by cot of 25. 90 minus 65 gives us cot 25. We divided by cot 25. This is equals to 1. So you see how this is useful complementary angles, because even if we don't know the exact value at 65 degree, we don't know at 25 degree, but we can simplify said equations using these results. Okay, let's say we are given an equation in terms of sine and cos, and we have to find the angle, like sine 3a, this is equals to cos of a minus 26. Again, sine of something equals to cos of 90 minus that. So cos of 90 minus 3a, this is equals to cos of a minus 26. Now since these two causes are equal, we directly can compare the angles. Get 90 minus 3a equals to a minus 26. This implies 4a equals to 90 plus 26, that is 100. 116 implies a is equals to 29 degree. This was quite easy, as we see. The thing to remember in this problem is that it must be specified that 3a exists between 0 and 90, and also a minus 26 exists between 0 and 90. Same with a. This is important because if this hadn't been the case, we could not have jumped from this step directly to this step comparing the angles. We would have to take a generalization that I will come to later. Let's do another example. We are given cot 85 plus cos 75, and the question is that we have to write this in terms of angles which are between 0 and 45 degree. Now how do we do that? It's simple. we just write cot of this as tan of 90 minus this. So we get tan of 90 minus 85 is tan 5, plus cos is sine minus 75, so this is sine 15. This was pretty easy, you just had to write them in terms of these angles. So we have done specific angles and complementary angles. We will move on to the trigonometric identities now. Okay.